Hi, good evening, everyone. I'm Paul at the Garland County Library, and I'm here to introduce tonight's program, Basic Astronomy and Telescopes. And our guest speaker tonight is Steve Skubish, who has been a member of the Hot Springs Village Stargazers Club since 2007. He moved here with his wife from Erie, Colorado in 2006, and after joining the Hot Springs Village Stargazers Club the following year, he quickly, as he describes it, came down with aperture fever, becoming very familiar with telescopes in the night sky, hosting stargazing parties, helping set up the Astronomy Day at the Mid-America Science Museum, and attending the Okie-Tex Star Party at Oklahoma's Black Mesa. So I'm going to let Mr. Skubish take over and start his presentation. And if you have any feedback of any kind, questions or remarks or comments about astronomy, just post them there in the comments, whether you're watching on Facebook or YouTube, and I'll read them to Mr. Skubish here when he's done with his presentation. So welcome, Steve, and thank you for joining us.
Thanks, Paul. Thanks for all your help. I'm going to go right to my PowerPoint presentation and talk about how I kind of got into astronomy and how I my journey through looking at telescopes and finding new things to look at every night. This is the first slide is the Orion Nebula. I'm going to be talking a lot about the Orion Nebula, but it's one of my favorite things to look at. And if you look out tonight, right around 9, 10 o'clock, before it gets too late, you can actually see this in the southwestern sky. As Paul talked about, my name is Steve Skubish. I'm an amateur astronomer. My wife and I moved to Hot Springs Village in 2006 from a small town, which almost exactly 8 miles east of Boulder, Colorado, called Erie. Not too many people know where Erie, Colorado is. A couple years after we moved here, I saw an article in the Village Voice, which is the local newspaper. The current president of the Village Astronomy Club was demonstrating a 14-inch reflector telescope. I was amazed at the size and the potential of such a telescope. My wife was very interested also, and so she decided we should join the Village Stargazers Club, which we did. Now, I was anxious to purchase a telescope and go on star parties with the club, but the members of the club suggested that I go to the star parties and just check out the different available telescopes before I buy one. Well, I just couldn't wait. I went ahead and ended up purchasing an 8-inch computerized Celestron Schmidt-Cassegrain Reflector Telescope. And I'll tell you what those are in just a few moments. I worked from my home office from 2006 to 2010, then I retired from IBM in 2010. And since then, we've enjoyed attending star parties wherever we can and going to those Okie-Tex star parties, which I'll talk about a little bit further. We have a viewing site on the village that affords us fairly dark skies for great viewing. We also have attended, like I say, the Okie-Tex star parties. I'll give more details on that in a moment. Let's talk about the types of telescopes. We have the refractor, which is the ones that involves lenses only. We have a Schmidt-Cassegrain, which is a reflector telescope. It involves mirrors. Then we have the straight reflector, which is like a Dobsonian, and I'll tell you the difference and some of the pluses and minuses of these different types of telescope. I'll also talk about my journey through these types of telescopes. And I started out with that Schmidt-Cassegrain, that 8-inch Schmidt-Cassegrain. But the main thing is what is up there to view. I mean, we all have probably looked through a telescope, or we bought a telescope, and the toughest thing you have after looking at the moon is what else is up there and how do I find it? I'll talk a little bit about Messier Objects. Charles Messier developed one of the first catalogs where he put together a catalog of objects. He documented it. He wasn't the first one to see all these objects necessarily, but he's the first one that documented them, and he documented them with M numbers, like M41, M42, etc. And then I'm going to kick off, or I'm going to highlight the evening presentation with how to use Stellarium, which is your best tool for planning your viewing on any given night. So anybody recognize this? This is your basic Tasco Bushnell $30, $40 telescope. At least they used to be that. And I think everybody's at one time or another had one or looked through one. After you look at the moon with it, you're pretty much done with it. It ends up in your basement or your attic collecting dust because it's not very user-friendly. It's got a spotter scope here. It's got the lens up here, the eyepiece back here, and the lens on the eyepiece. But it's very small field of view. It's very difficult to see anything except for the brightest objects that you can pick up in the finder scope. So its utility is not very good for beginning astronomy. As I said, the refractor telescope is just a tube. It's got a lens right here at the end of the tube where the light comes in, goes through the tube, goes through an eyepiece lens, focuses into your eye, and you're able to see objects magnified at various magnifications. A lot of those scopes advertised 300 power or more, which is pretty useless when you have a very narrow field of view. This is a little bit larger refractor telescope that I've got here in the bottom. The Schmidt-Cassegrain telescope is the kind that I started with. Mine looked a lot like this little one here, this little orange one in the bottom right. This is a Celestron 8-inch, and it's a go-to telescope. It's actually got a computerized go-to system on it. This little thing that looks like a telephone receiver here, you can punch in Messier numbers, NGC numbers, whatever catalog of item that you wanted to go look at, and it'll actually motorized, will go up and down and back and forth, and it'll actually end up right on the object that you selected. So once again, you can start looking at things instead of looking for things. I'd like to back off a little bit and show you a Schmidt-Cassegrain telescope. It's not the one that that I had, like this little orange one here in the bottom, but it's one that was donated to the club by a very nice lady. And let me go right here. There I am. This is a Mead 8-inch Schmidt-Cassegrain telescope. This is old technology. This is a 1980-85 version of Schmidt-Cassegrain. Once again, the light comes right in through the front here. There's a glass corrector plate right here. Goes in, hits the mirror, the paraboloid mirror in the back, reflects back up to a secondary mirror, and then it shoots it straight back through a hole in the paraboloid mirror out to your eyepiece here in the back. This is the eyepiece, usually has a, you can put the eyepiece straight in, or you can put a right angle like this right here and put your lens or your eyepiece right in here. This is a Nagler 7mm eyepiece, and it gives you some great magnification. Here's your spotter scope. Once again, this has a better field of view than that little Bushnell or Tasco, but it still is hard to find things without the computerized go-to capabilities. So this is pretty nice, but like I say, the newer technology with the computerized devices on them just make it so much easier to find things to look at. Okay, let's go back to the PowerPoint. Slideshow. Once again, the Schmidt-Cassegrain optics, the light comes in through the corrector plate, which is right here, hits the paraboloid, convex paraboloid mirror, focuses it back into the secondary mirror, and the secondary mirror reflects it back to the eyepiece through the hole in the paraboloid. I'll be talking about focal lengths of telescopes here in a few minutes, but basically the nice thing about the Schmidt-Cassegrain is the light path goes back and forth a few times. It gives you a longer focal length, and longer focal lengths help you get a little bit better magnification. So that's your Cassegrain telescope. I loved my little 8-inch Cassegrain telescope, the Celestron that I had, but I caught like Paul said, I caught aperture fever. And one thing you find out in telescopes is the bigger the mirror, the better. So I went ahead and took the dive. And I got this telescope right here. This is a Dobsonian telescope. You're the most simple reflector that you can have, and I'll explain how it works in a few minutes. This is the Okie-Tex. This picture was taken at the Okie-Tex Star Party. The Okie-Tex Star Party they have every year, except for they canceled it last year due to the virus, but they have it every year, and it's right up in the corner of the Oklahoma Panhandle. It's on the Black Mesa, beautiful, barren, high plains is what it is. And if you ever wanted to know how the dust devil days came through Oklahoma, all you got to do is drive up here, and you can see there's nothing to stop the wind coming from down there. This is my van right here. This is my little pop-up camper. This Dobsonian telescope has a computer on it right here. It's got a rocker panel right here. The mirror is in the bottom of this rocker panel, and you can see it rocks back and forth, which gives you your elevation or declination. Goes up and down. This whole box here rotates on another motor to give you your right ascension or your left and right. So basically, I go up to this little control box up here and punch go to after putting in the computer what I want to see. And then the stepper motors make a real funny noise, but the telescope basically swerves around, gets the right ascension correct, and then the declination rises to where it needs to be to find whatever object you're trying to look at. This is a great star party. Every year, you're really roughing it. This is my camper right here. There's no plugins. You're roughing it for 1 week. In the last star party we went to at Okie-Tex, there was 350 people. So there's a lot of astronomy nerds that attend. There's meetings, there's presentations, and a lot of camaraderie. And everybody, you learn quite a bit by talking to those people up there. We look forward to going back again once the virus is under control. So the reflector, or Dobsonian or Newtonian telescope, is just a tube with a huge mirror at the bottom of it. The light comes in through the opening at the open end of the tube, hits that paraboloid mirrors, similar to the Schmidt-Casa grain, reflects it back to a secondary mirror, but instead of like the Schmidt-Casa grain reflecting it back through the hole in the mirror to the eyepiece, it does a 45-degree angle and kicks it out to your eyepiece that's hooked onto the side of your telescope. Very simple, very simple. And the eyepiece is right here. I'll show you another picture of a Dobsonian world. You'll be able to see where the eyepiece mounts. Not a lot of focal length on this because you're not bouncing the light path back and forth, but the focal length on this thing is basically the length of the telescope, which is 8 feet. This thing is 8 feet tall. I want to talk about magnification. I've been talking about focal length. Magnification is one of the things that everybody jumps at right away. They want the telescope with the best or the highest magnification that they can get. You determine the magnification by taking the focal length of the telescope and in millimeters and dividing it by the eyepiece size in millimeters. That 22-inch Starmaster that I just showed you has a focal length of 2,400 millimeters. When converted, it converts to 8 feet. If I put a 7-millimeter eyepiece in it, you take the 2,400 millimeters divided by 7 millimeters, and it yields 343 magnification, which is quite a bit. That's about as much as I like to use on deep space objects like galaxies, globular clusters, and nebulas. And you can play around with magnification on whatever you're looking at. The more magnification you get, the less resolution, less clarity that you have of the picture, almost 100% of the time. So it's a balancing act between magnification and light collection. With that 22-inch mirror on the Starmaster telescope, light gathering is at the optimum. The 14-inch Schmidt-Casa grain that our former club president had has a 3,600 millimeter focal length. You put a 7 millimeter eyepiece in that thing, and you got 514 times magnification, which is obscene. That's quite a bit, and hardly ever used. And then if you really want to get crazy, you can put a Barlow lens underneath the eyepiece, and it basically doubles the magnification. So that's getting obscene. It's all about light gathering, which is most governed by aperture size. That's why I put the focus on light gathering. What you're going to look at when you go outside? Well, some of my favorite things are globular clusters. Talk about them in a little bit. Galaxies, of course. These are deep space objects. These are things that would be very difficult to find with that little Tasco telescope that I showed at the beginning. Galaxies, once again, these things run the gambit. I mean, some of them, like Andromeda Galaxy, are almost visible by the naked eye, but some of them are millions, tens of millions of light years away, and you need a good telescope with great light gathering capability to be able to pull those in and see them. Nebulas are mostly just exploding stars that have left their mark, and there are some beautiful nebulas out there, and I'm going to show you a couple of those. Double stars I'm not real excited about, but I'll tell you what, we have some of those astronomy nerds that go up to Okie-Tex. They'll spend the whole night trying to resolve double stars. And I'll try to remember to show you an example of that when we get on Stellarium. And then, of course, we all know about planets. When we first got my 8-inch Celestron telescope and brought Saturn up with its rings, my wife she was sold. She loved that. And it's a sight to behold. I mean, it's not like looking at it in a book. Seeing it for real is just an experience. It's a lot of fun. All right, let's start with globular clusters. The Hercules Globular Cluster is one of the best ones to look at in the Northern Hemisphere. And Hercules will be up later on tonight. But this is the constellation, the Hercules Constellation. The Hercules Cluster is right along this border of the constellation. In a low powered telescope, this is what you would see. You can see it's a very compact mass of stars right in the middle. And we're talking about hundreds of thousands of stars. Now, if you want to look at it through my Star Master with a 22-inch mirror and a 7 millimeter Nagler eyepiece for 343 magnification, this is what you're going to see. Hercules is a Messier object. It's M13. It's about 145 light years in diameter, but you know, it's just packed in there. It's composed of several 100,000 stars. Magnitude's 11.95. You can almost see it with the naked eye, not quite. You can definitely see it as a little smudge with binoculars. And this is an average of 22,000 light years away from Earth. So whenever you're looking at the light from one of these stars, you're looking at something that left the source 22,000 light years or 22,000 years ago, which is kind of hard to get my head around sometimes. The Andromeda Galaxy is the closest galaxy to us. It's also you can almost see it with the naked eye. If you had a really clear night, you might be able to see it. You can definitely see it with binoculars. It looks like a little cotton ball out there, a little elongated cotton ball through a telescope. This is more of a Hubble type image where you can get a little bit of color and you get a little bit more granular view of what it looks like. But it is the closest. It's 2.5 million light years away from the Milky Way, which is kind of a good thing because it's headed our way. Sooner or later, they're saying it's going to collide with the Milky Way. And but I don't think we have to worry about that for a long, long time. Another galaxy that I like to look at is the Boge Galaxy. The Boge Galaxy is a Messier Objects. It's M81. And first of all, when Messier described it, he described it as a nebula. He called it Boge Nebula because it just looked like a smudge of light. So he thought it was a nebula. It wasn't until more powerful telescopes came along that we were able to resolve that it was a galaxy. Right next to M81 is M82, which is also part of Boge Galaxy. Not part of it, it's a separate galaxy. It's often called the Cigar Galaxy. This is more of a Hubble view of it right here. Through a telescope, you're going to see the elongated Cigar Galaxy, with good light gathering capabilities and a high power magnification. You can see some structure within the galaxy. You will not see this color that you see from the Hubble's telescopes. But basically, considering how far this thing is away, it's amazing to take a look at it. The Boge Galaxy is just right off the Big Dipper, the bucket of the Big Dipper. It's just a few degrees off of the bucket, so it's somewhat easy to find. We'll look at that on Stellarium in a minute. The Orion Constellation, once again, is my favorite. There's so many things to look at, and we'll look at it on Stellarium here in a minute, but this is what it looks like if you look out tonight, before too late, before it sets in the west. This is the belt stars. The Orion Nebula itself is right in this little area right here. This is Betelgeuse, or Betelgeuse they call it. That's the red giant. This thing right here is so huge that if you put that where our sun is, it would engulf all the planets all the way out almost to Mars. That's how big that red giant is, which would not be good for us if it happened to swap places with our sun. This little star down here is Sirius, which is the largest, most visible, it's not the largest, but it's the most visible, most luminous star that we can see in the Northern Hemisphere. So let's take a look. What does it look like? This is a Hubble view. Once again, this is the Orion Nebula. You can't really see the triangulum, but there's 3 stars in here that kind of light up all the dust and all that's going on. The star nurseries, they're building stars. And like you see, there's a lot of nebulosity all around the Orion Nebula. Through my telescope, if I use a high contrast nebula filter, I can't get the color, but you get a black and white monochrome view of this, and it's spectacular. If you look at it without the filter, it just looks like a white picture. But when you put the nebula filter on it, it actually almost makes it look 3D. A lot of fun. This is one of my favorite things to look at. The Ring Nebula is one of the few nebulas, it's one of the few items in the sky that you can actually see some of the blue through a telescope. Most of them are all monochrome. This one is nice enough where you can actually see the blue. It's a beautiful, as you can see, it's a very beautiful nebula. A lot of fun to look at. Usually it's very high in the sky. And you can see this with a lower power telescope. I put the large telescope when I'm up at Okie-Tex. I put it on it to see if I can resolve the star. There's actually 2 stars in the middle of the nebula. Very difficult to see unless you have a very clear night and good viewing. Here's another view of a Dobsonian telescope stripped away so you can see what's going on. Once again, the light comes through this upper tube assembly. Not much of a tube there, it's just a frame. Light comes down, hits the paraboloid mirror, kicks it back up to the secondary mirror, which kicks it 45 degree angles out to your eyepiece. This is how all of them work. And you can change eyepieces right here. This is your focuser. Runs the eyepiece in and out to get your object in focus. This is a red dot finder to kind of help you line up the telescope on what you want to look at. This one doesn't appear to have any electronics on it. So this is a push to. You have to know where the objects are in the sky, and you got to find them manually. Through my Dobsonian, my StarMaster Dobsonian at Okie-Tex, I put a 40 millimeter eyepiece in it. Just threw my cell phone up there and was actually able to take this picture. This isn't recommended. It was kind of difficult to get one that was in focus, but actually shows you what you can do with a cell phone and a telescope. Here's the Messier objects. This is just a few of them. This is 1 through 31. There's actually Messier's original catalog had 100 objects on it. It's been expanded to 110 objects now. And the Crab Nebula, a lot of fun to look at. That was Messier number 1. The Lagoon Nebula is a great nebula. It's like a small Orion Nebula with a dark area that goes right through it. It's like a shadow. Interesting to see through a telescope. Wild Duck Cluster is a popular open cluster. The Hercules Cluster, once again, is Messier 13. I already showed you a picture of that. The Eagle Nebula is the nebula that contains the pillars of creation. When you look at the Eagle Nebula through a telescope, you're not going to see the pillars of creation unless you take a picture of it. You take an astronomy long exposure picture of the Eagle Nebula, you can see the pillars. It's not going to quite look like it does through the Hubble. Definitely not going to get the colors, but you can see the star-making areas of the Eagle Nebula. Trifid Nebula is a lot of fun to look at. Dumbbell Nebula is one of my favorites also. It actually looks like a dumbbell, and you can actually see a little bit of color in the Dumbbell Nebula too. And then, of course, M31 is the Andromeda Galaxy that we already talked about before. So this is what is out there, just a touch of what's out there, and showing you what some of them look like. But let's go ahead and see what's really out there. Let's look at everything. If you go to stellarium.org on your computer and download Stellarium, basically it'll have some windows in the upper right corner. You click on your Windows 10 version. You can click on a Apple version if you need to, but click on the Windows 10 version if you have Windows 10, and it'll download Stellarium onto your computer. It's free, it's updated frequently, and it's just a great tool. So I'm going to go to Stellarium now and show you how it works. Okay.
Hey, Steve, just click on it on the desktop. Yeah, the Stellarium icon on the desktop. You see that?
Oh, okay. I got lost there a moment. Pardon me. Okay, let's bring up Stellarium. This has already been downloaded. It's a very large program, but when you see what it does, if you're interested in astronomy, you got to get it. Okay, there it is. Isn't that impressive? Can't see a thing, can you? Here's how it works. Go over to the left. You just put your cursor over here to the left. You go up to the location window, and you put in your location. This is, mine says Hot Springs Village. This Garland County Library has Hot Springs in it. It shows you the latitude and the longitude of this location. So it shows you what we've got here. Also, let's say we're going to go out tonight. We want to see what's out there tonight. Let's say like at about 10 o'clock, 2200. Okay, now, of course, it's dark. We're starting to see some stars. Still not much to look at. So let's go down here. Let's put in some constellation lines. There we go. Now, I don't know what any of these constellations are. So let's go ahead and turn on the constellation labels. Now we know what the constellations are. Here's the Orion constellation right here. We also can go into take out the ground or put the ground back in. Atmosphere, you can see it's kind of blurry around here. It's simulating atmosphere. We don't want that. We want to go ahead and make it as clear as we can. Here's the best one to click on right here. This is your deep sky objects. That brings in all of your galaxies, globular clusters, open clusters, things that we want to see. So basically you can go through this is what tonight's sky, that's tonight, is going to look like at 10 o'clock. As you can see, the Orion Nebula is sinking in the west, so it's not going to be out too much past 10 o'clock. So let's take a look at what's in the Orion Nebula, because there's a lot of things going on. As I zoom in on it, what I'm doing is I'm scrolling through on the mouse. I'm turning the little wheel on the mouse, and it brings it in. So what you can see here, here's the Orion Nebula right here. Here's Alnitak, that's the first belt star. IC 434, this is the Flame Nebula. And if we pull in a little bit further, you can see all the nebulosity here. This is the Flame Nebula. This is Reflection Nebula right here. This is the Horsehead Nebula. If anybody's been around astronomy for any amount of time, they're always looking for the Horsehead. It's a reflection nebula. It lights up with the stars behind it. You actually need a hydrogen beta filter to be able to see it. I've got 2 hydrogen beta filters, and I still haven't been able to see this. It takes excellent viewing conditions to be able to pull it out, and I haven't been able to do it yet. One of the gentlemen in the astronomy club has a very nice astronomy camera, and he's taken pictures of it, and it's come through very clear. So that kind of shows you the Orion Nebula, the Horsehead Nebula, the Flame Nebula, Casper the Friendly Ghost Nebula. I've never looked at that. And of course, whenever you want to zero in on something on Stellarium, you just click on it. It says Great Orion Nebula. Click on this little icon here. That centers it. And then when you zoom in on it, it stays right in the view. So that's the Orion Nebula on Stellarium. So I'm zooming back out. Here's Sirius. There's the Sirius, the brightest star in our sky. There's Betelgeuse, the red giant. You can see all these clusters. These are star clusters. Oh, one thing I didn't mention on the Great Orion Nebula, the magnitude is 4.0. So that you can basically see this little piece below the belt star. You can see a little bit of light coming from here. That's part of the Orion Nebula. And a magnitude of 4, the smaller the number, the easier it is to see. It's got all this data in here. But if you go down to the distance, it shows you right here that it's 1,343 light years away. So what I tell the college students when they came out to look through my telescope once, I told them that with the light that they're seeing from the Orion Nebula through my telescope left the source right around the fall of the Roman Empire. That got some oohs and ahs. Let's see what else we're going. We're going to the southwest now. The Beehive cluster. We can zoom in a little bit. When you zoom in further, you pick up more and more deep space objects. It kind of knows that you want to see something little bit deeper. Where are we? We're south. We're in the south now. These are galaxies. This is NGC catalog. Your favorite catalogs, or my favorite catalogs, are Messier catalogs and NGC catalogs. These are on the computer on my telescope, so I can bring up the catalog and I can punch in these numbers and it'll bring me to this galaxy. Let's see what this galaxy looks like. First, we'll center it using that little icon, then we zoom in. And they don't have any data on it. I wasted my time there, I'm sorry. This thing is constantly updating. Got the Pinwheel Galaxy. Here's M68. That's a globular cluster. Let's take a look at what that looks like. Another globular cluster, sort of like Hercules. You can see, yes, it is a globular cluster. You can see right here, I've got the meteor shower turned on. So it's telling you where some meteors might come out of Virgo. There's Arcturus. Arcturus is a very bright star, one of the brighter stars in the sky. And it's called Arcturus because this is the Big Dipper. And the handle of the Big Dipper comes down here, and the handle points to Arcturus. So if you ever look past the handle or in line with the handle down from the Big Dipper, the bright star you're going to run into is Arcturus. You know what that star is. Mizar is one of our double stars. Let's see how it resolves. We center on it, we pull in. You can see it's a double star. It's actually a triple star. And that's what's fun to look at through your telescope. If you got the right viewing conditions, the right telescope, the right eyepiece, you can resolve those double stars. As you zoom out from it, you can see it just looks like a star. There's the Little Dipper. There's your North Star, Polaris. Here's our Boge Galaxies. Boge Galaxy is 11 million, almost 12 million light years away. So when you're looking through this thing through the telescope, it's just amazing that we're able to see it. Let's zoom in on that. And I already showed you a picture of it earlier in my presentation. There it is. There's Boge Galaxy. This is M81. That's a face-on galaxy. This is M82, known as the Cigar Galaxy. Boge Galaxy. And it's right there up by the Big Dipper. So what else we got here? We're in the northwest here. Capella is a very large star, bright star. We kind of pay attention to the bright stars because we use them for alignment of the telescopes. When you have a computerized telescope, normally you take two bright stars and you enter them into the computer while you're pointed right at them. And then by doing that, the computer basically knows where everything else is in the sky. And that's very handy to have. So you punch in the numbers and you just go right to looking at things. Let's go back to the eastern sky. Not much there right now, but let's say we want to stay all night and look at stars. I didn't want to do that. Okay, so we're going to set our time. I'm going to go in through the night, 1 o'clock in the morning, 3 o'clock in the morning, 4 o'clock in the morning, 5 o'clock. I didn't want to do that. As you can see, everything comes up in the east. And you can see by 5 o'clock in the morning, we got Saturn coming up, the moon's rising, and all kinds of different things. Here's your Hercules Globular Cluster. It's risen. So basically, if you stay up all night, you get a whole different sky. And you can tell exactly what you're looking at using Stellarium. Okay, that's about all I had to show you. Like I say, this is the highlight. Using this particular tool can save you a lot of headaches when you're wanting to go out and look at what's up in the sky and you don't know where anything is. This will tell you everything you need to know, and then you can go out and find them. So, Paul, that's all I got. If anybody's got any questions, I'll be glad to answer.
Well, Steve, I appreciate that tour of Stellarium. That's a really cool program. Mario, you were talking, I looked it up, and it is available on iPad as well for convenience to take it out with you and refer to it in the sky. So let's see. My first question for you is the Milky Way actually made of milk? That's my April Fool's Day question.
That's an easy one. No, the Milky Way is an arm. It's several arms. We're on the Sagittarius arm, I believe, of the Milky Way is where we're located. There's several arms. And it's just the arm that we see at night comes right into, if you look at the southern sky, you can see the Milky Way coming out of the southern sky at certain times of the year. And when we're up at Okie-Tex, it's so dark up there. There's absolutely no ambient light because there's no cities with light pollution anywhere near. And the Milky Way actually throws a shadow. And when I first went up there and I was setting up my telescope, I was having trouble finding the North Star because there's so many more stars that you can see because of the seeing conditions. And that's why they have star parties in a location such as the Black Mesa.
That was actually a question I got earlier today. How do you find the North Star?
Well, we find it right off of that Big Dipper. If I could bring up Stellarium again. You can find it right on Stellarium just by when I brought it across to the Big Dipper and I was actually on Stellarium. We'll do it real quick. Well, let's go back to Julian. Okay, we go to constellations, labels, go to the north. Once again, hope everybody can see this. This is once again is the Big Dipper. This is the Little Dipper. You line up these two stars off of the Big Dipper, and they basically point to the North Star. That is Polaris right there. North Star, there's no other bright stars very close to it, unless you go up to Okie-Tex, then it's harder to find. But that's how you find the North Star.
While you're there, as a kid, I liked looking at the names of constellations, but didn't have a telescope to actually, and I'd look at pictures. But over to the left of the Little Dipper is Camelopardalis, and I always thought that was the coolest name, but it's not a very impressive constellation compared to the others. No,
and there's not a whole lot in it. It's got this one, the Jolly Roger cluster right outside of it. But there's a galaxy right there. But yeah, there's not a lot going on in that cluster. I don't know where they, if you want to, we can put the art up too.
Very nice.
There's your art. So it looks like some kind of an animal.
Yeah, giraffe.
So of course, I don't do this because it's a little distracting, but this shows all of your the constellation art. Of course, here's Ursa Major which is the bear, the lynx. So yeah, a little distracting, but you can do it right here on the constellation art.
Right. Good point of reference for people who know, the astrological signs, and that's kind of their only point of reference for what to look for.
Yeah.
While you have this open, we talked about earlier how Sirius is the brightest star in the sky. We had a question from Whitney. What's the biggest star?
Oh, probably Antares might be the biggest. It's not visible right now. It's not till early fall can we see it, but it's way down. It's in the south sky. It would be right in here. And it's called Antares because I guess Aries was the name that they used for Mars. And Antares is a red giant, and it's huge. I can't remember the statistics on it, but it's probably one of the biggest stars out there that we can actually see. And it's called Antares because it's not Mars. It's anti-Aries. It's red and it's giant, but it's not Mars.
So what is your personal favorite time of day this time of year to look at the night sky?
The later the better. It doesn't really, once the time changed, it doesn't really start getting really dark until about 10 o'clock.
Mm-hmm.
And the later you stay up, the darker the sky gets. I think some of the city lights are toned down a little bit because you can see from the Hot Springs Village, you can see the glow of Hot Springs. You can see a little bit of the glow of Little Rock, and you don't want that. You want to minimize that. But usually about the time we're packing up and going home is when the best sky is available, as luck would have it.
And I was going to say it's probably a lot easier in rural areas where you don't have the light pollution. But in your experience, what parts of the village or the city or the county are the best spots to set up and view the sky?
Well, our viewing site is right off of the main road that comes through the village, and it's the village storage units are right off of the main road to Soto, and there's a little road that winds back into the trees, and then there's a large opening. We actually had the village built us a platform there out of road rock, and that's where we set up our telescopes. And it's pretty much out of the line of any ambient light or any light pollution. So it's a relatively good place to look at. Of course, by going up to Okie-Tex, you're gaining altitude because you're at 4,000 foot altitude there. So that's 4,000 feet less atmosphere that you have to look through. Plus your air is normally very dry. So less humidity or anything like that to mess up your view.
And 4,000 feet isn't a lot when we're talking about space, but does it really make that much of a difference because of the atmosphere?
Yes, it does. It's a combination of that and the drier air. Like I say, up at Okie-Tex, and also the no ambient light. There's no light pollution up there because you're in the middle of nowhere. And like I say, the sky looks completely different. Like if you looked at the sky in Little Rock with all the light pollution, and then you looked at it in Hot Springs Village where we do our viewing, the sky looks completely different. You could see many more stars, and you can see things much more clearly. And then you go from where we view on the village up to Okie-Tex, up the Black Mesa, and it's that much, again, better.
Someone sent me a question earlier. What are stars made of?
Basically, I think they're hydrogen. I'm not up on that very much, but basically it's hydrogen. There's nuclear reactions going on all the time. I used to know this, but I just can't really quote it right now, Paul.
Brooke wants to know, how do I find out about astronomical events?
One of my favorite sources is YouTube. If you go on YouTube and probably just search on what's in the sky tonight or something to that effect. There's all kinds of videos that come out each month. It basically tells you, okay, here's what the sky is going to look like in April. There's one out there right now that does that. It shows you constellations. It gives you a few little tidbits of what's going on. But yeah, if you just search on YouTube or just search anywhere on the internet for astronomical events, you'll probably get bombarded with things.
Someone mentioned Pathfinder. Are you aware of that?
Pathfinder?
Pathfinder.
What is Pathfinder? I'm not sure.
I'm not sure. That's just something someone mentioned. I'll have to look it up.
Sounds familiar.
Let's see. What is there a certain type of weather that's best to view in, or I've heard the rain has an effect that's better after it's just recently rained.
Yeah, when a cold front comes through and the air dries out, that's the best time to go. There's actually a website, I can't remember the name of it right now, but it's a viewing website, and for a given location, it gives you the condition of the sky for astronomical viewing, and it talks about transparency, clarity, humidity. It takes in all the factors, tells you how good the sky is for viewing at a given time, on a given night. So one of the things we use to plan our star parties, if we look into that site and it says our skies are supposed to be really good tomorrow night, we may schedule a star party just based on that information. Sorry, I don't have that information at hand.
Jennifer on Facebook just asked, what type of telescope would you recommend for a beginner?
Well, I've kind of put out the pros and cons. Starting out with a Schmidt-Cassegrain has a lot of benefits to it. They're a little bit tricky to align when you try to do a two-star alignment with them. The easiest telescope to use is the Dobsonian, which is like my Star Master. And you can get it with electronics and computer, or you can get it just push to. And the nice thing about the Dobbs is you can get a much larger mirror for better light gathering for the bang for the buck. And I really like Dobbs, but I also like Schmidt-Cassegrains as long as they have go-to capabilities. But you have to be patient. You have to learn how to align them so that when you go out, if you align them correctly, all you got to do is punch in these numbers, like these Messier numbers or the NGC numbers, and it'll zip right to them, and you can look instead of search.
So earlier you were telling me about computerized telescopes. Could you share that info again?
Yeah, what we call them is go-to, because what you do is you punch the number, the Messier number, the catalog number, the NGC number into the computer, and then you hit go-to, and it goes to the object using the computer and the stepper motors to drive the telescope left and right and up and down till it finds that object. There's various kinds of computers. And like I say, my son just bought a telescope that it's a reflector, smaller reflector, but he basically just straps his smartphone to it with the app that came with the telescope, and he can punch it into the phone and then push the telescope back around. The phone will tell him when he's lined up to the object. So there's various types of go-to capabilities. The one on my Star Master, my 22-inch Star Master, is it's a $350 computer. It's kind of basic, but it has lots of catalogs on it, and it's fairly easy to use. You just punch in Messier M and whatever number you want to go to, hit go to, and it just drives it right to the object. One of the things, if you're first buying a telescope, if you can get a go-to capability. That's the thing to do, because I can sit here and show you all this neat stuff on Stellarium. But if you're going to go out there and just try to point a telescope at these objects, you're going to have a double of a time trying to find them. So my suggestion would be to get something with go-to capabilities. And like I say, you can spend a lot of money on them, or you can get one that works off of your phone and get it a lot more affordable.
Are there any books or guides or resources you would recommend for people getting into this?
There's tons of books out there.
Sure, we have plenty right behind me.
Probably have a lot of them here in the library. But I get most of my information just off the internet. Everything's out there as much as you want. There's a lot of guides through YouTube. You go on YouTube and the guy has a video out there, shows how he photographed Orion. And, you can find almost anything you want on YouTube. But I've got some books and I haven't read them all yet.
Jill had mentioned, can you buy a star or have one named after you? Or do you know what she's talking about there?
I'm sure somebody will sell you a star if you want.
And you get it named after you, adopt a star.
I don't know if that's legit or not, Paul, to tell you the truth. I really don't know. I've heard of that before, but I don't know if it's legit. I mean, I don't know how you can do it and control it.
But is it
stars out there for everybody?
But is it true if you discover an object in the sky that you get to name it?
Normally, yes. Like an asteroid or a comet. If you discover it, yeah, you get to have a say in what it's named.
Has anyone in your club had that honor yet?
No. That's hard to do. You got to spend a lot of time looking to find something like that. But I read about it every once in a while where somebody has discovered something that they didn't discover before. I wanted to mention on that 14-inch Celestron or Mead telescope that our former president had that got me turned on to all this. We actually saw Pluto through that telescope. I was mentioning the amazing amount of magnification that you can get out of it because of the focal length. But my wife and I are on a short list of people that have actually seen Pluto through a telescope. Now, it was just a little pinpoint. It was just a little prick of light, but we saw it. It was Pluto.
Have a fun question from Brent. What planet could you throw a football on the farthest?
The smallest one, the one with the least amount of density. Oh boy, probably Mars. I think Mars is bigger than Venus. But anyway, yeah, whichever planet has the lowest density, and I'd have to look at that data to find out. The moon, you could probably do it further than any of the planets.
All right, let's see. Looks like that's all I have for you. Are there any other fun trivia facts you'd like to share with us, or just anything in general that you would recommend for people getting into astronomy and stargazing?
No, if you've got the bug, like I say, going out and actually being able to see some of these objects, especially the deep space objects, is very rewarding to be able to find them and to see them through a telescope. And if you do that, you might catch the bug. Like I say, when Saturn comes up later on in the year, Saturn will be more in view. And if you have a chance to look at Saturn, take a look at the rings, because it is spectacular. It's really something to watch. It kind of moves me when I see it. Jupiter is fun to look at too, and it's huge. And you can actually see the 4 moons of Jupiter. That's a really great thing to look at. And you can see the moons even with a smaller telescope. With my larger telescope, you can actually see the shadow on Jupiter cast by the moon when it's in the proper angle as far as the sun hitting the moons. But those little kinds of things like that are just kind of make it all worthwhile to me. And that's what I suggest.
Other than the moon itself, what would you recommend as kind of the first thing people gravitate towards trying to observe?
I'm going to promote the Orion Nebula. Of course, if you want to see that, you got to see it now or wait till probably around September, October timeframe when it comes back around. But it's fun to watch. You can see it with a pair of binoculars all the way up to, if you use a small telescope, you can see it a little bit better. If you got a large telescope, you'll get some of the spectacular views that I've shown you tonight. That's one of my favorite things. And other than that, like I say, Jupiter is great to look at. Saturn is great to look at. And then other than that, if you can see any of these deep space objects like the Ring Nebula, but that takes a little bit more work to be able to locate those and see them through your telescope, unless you have a Bluetooth.
And yeah, on Orion, that belt's pretty easy to spot too.
Yeah, that's the most easiest to recognize in the sky. And like I say, it's only going to be up for a little while longer. It'll be setting earlier and earlier.
Well, Steve Skubish, this was very informative, and I appreciate this little guided demo tour of Stellarium here. Give you a chance to say anything else before we go, and tell them where they can find out more info about the Stargazers Club, and thank you for your time.
Yeah, thanks a lot for all the help, Paul, for setting all this up and backing me up. I just want to thank everybody for sticking with me tonight. Hopefully you got something out of this and I helped you out. You can look up Hot Springs Village Stargazers on Facebook, get a little bit more information, get the phone number of the president of the club, or my wife's the vice president of the club, and they'll be able to help you out. If you want to get your name on a list whenever we go out to star parties on the village, we put you on a list and we will contact you whenever we're going to do that. And it's hit or miss, we will schedule a party and then the clouds will move in or something will happen and we've got to cancel. That happens more often than not. But every once in a while we get a great night. We go out there and just have a great time looking at everything.
Do you have to be a village resident to join, or
you'd have to contact one of us and we would give you access. We'd leave your name at the gate.
Excellent. All right. Well, thank you for your time, and hopefully we'll do some more astronomy programs throughout the year.
Thanks a lot, Paul. Thank you, everybody.
Take care.